G'day, I'm Glenn Morris from the Smart Energy Lab, and today I've got an old but young friend coming to visit me. Peter Watkinson. Now, a bit of a backstory there. I've known Peter's mum, who ran the company long before I knew Peter. Peter's dad actually was the inventor of the maximum power point tracker. Amazing story. Back in 1983, I think, as a young engineer in Queensland. Unfortunately, his father passed away when Peter was quite young, and his mum took over the business. She's not an electrical engineer, but she did a pretty good job at keeping it running until Peter was old enough really just to take over the reins. Now, Peter has stepped up this process a whole lot more, and in fact, the company has grown wonderfully in terms of product range and volume. Peter has come and visited me quite a few times here at the Smart Energy Lab, and we've talked lots of geeky stuff about solar charge controllers. So the latest units that AERL, which actually stands for Australian Energy Research Labs, that's what his father founded it as way back in 1983, I think. The three models that I'm looking at are the Coolmax SRXs. Now, this is kind of like their reboot. They've done a few versions of the SRXs. This one comes in a range of sizes on the SRX 600, which is suitable for both 24 volt and 48 volt battery systems. At 24 volts, you really want to max out at around about 1.5 kilowatts. At 48 volts, a bit over 3 kilowatts of PV. The next step up is their 70 to 48 range, and that will do 2 kilowatts at 24 volts and a bit over 4 kilowatts at 48 volts. And then you move up to the big boy, the SRX 600, 30/120. It will give you about 4.3 kilowatts of PV at 120 volts out. So really suits those higher voltage battery systems. Now, these units are one of the very, very few units in existence that actually have a functioning and compliant earth fault alarm built in. So you don't have to go and buy an extra earth fault alarm system, which actually costs nearly as much as some maximum power point trackers. So that's a win. On-board earth fault detection, 600 volt maximum input. So wow, no more little 2-3 panels in a string and going, oh, I'm maxing out my MPPT. Now you can go up to 600 volts, which is pretty similar to most on-grid solar inverters. It's of course Australian made in Queensland at the AERL facility. So it's a great story. But anyway, Peter's going to arrive in a minute. And let's get into talking tech about the AERL range of charge controllers. G'day, Peter.
G'day, Glenn. How you doing?
Good to see you. Rocking up in an EV.
Yeah. Why not? It's the way to go, right? Can't go wrong.
Yeah, I've never seen a Polestar before. I'm walking around and saying, what sort of brand is that? I couldn't work it out.
Yeah, they haven't been around for very long, but they're Volvo's first attempt at an electric vehicle, and it's pretty good.
69 kilowatt hour battery.
Yeah, it's decent sized battery in it.
Yep.
Can't go wrong there. I still think the Tesla has it by a little bit.
You got a Model 3, haven't you?
I have a Model 3, yeah.
Yep.
So I'm a little bit biased, but also I'm trying to be objectively. I think it still has it by a little bit. But considering first attempts, not bad at all.
Does it have insane mode or what it is called?
No. So the car itself, fantastic. The power electronics, Tesla. That's where Tesla pulls ahead.
Right.
Yeah. So. If there's anywhere for them to improve, that's the spot.
Yeah. Cool. Hey, thanks for bringing your MPPT along. So what are we looking at here?
You're looking at one of the SRX 600 generation chargers. So this is our latest bit of kit. 600 volt input, onboard ground fault detection, and all the bells and whistles you could possibly want.
Wow. So the SRX range have all gone to 600 volts?
Yeah, so the old 300 generations have now been 300 volt generation's been discontinued.
Yep.
And this is the replacement.
So this, from looking at your data sheet, this is the current one on your website.
Yes.
So there's the 2448. Now, why is it called 55-50? 48.
So that's a 55 amp 48. So that's our 3
Oh, I
kilowatts.
see. It's amp and output
Yeah,
voltage.
that's right. And then there's the 7048, which is the 4 kilowatt.
Yep.
And then there's the 30 amp 120 volt version, which is a bit over 4 kilowatts as well. For
Gotcha.
those 120 volt systems.
Right. So the smaller units can be programmed to do 24 or 48.
That's right. Yeah.
Oh, that's
so
nice.
they're predominantly 48 because
Yep.
we find 24 is not super common these
Yeah.
days. Just
Yeah.
doesn't make sense most of the time. But they can do 24 if you
Well,
want to do that.
I'm really excited to see 600 volts on MPPT. That just makes life easy.
Yeah, so this is really our first offering that actually actively competes with AC coupling.
Yeah.
Right, you can put this up against a Fronius and really give it a run for its money.
So if this was the 120 volt version, would it look the same?
Yes, it does.
So same form factor. So we're looking at something that could take about 4.3 kilowatts of solar.
Mm-hmm. Well, that's nominal, right? So you
What
can
does this
actually
weigh?
oversize it quite a bit more than that.
Oh, really?
So yeah, so that's continuous.
That's just
continuous output
without
power.
clipping.
Without clipping.
And what would you recommend for maximum PV input?
Sort of maximum PV input. Right now we're looking around the 140% mark.
140%
Yeah.
oversizing. Nice.
Yeah, so
Yeah.
quite a good oversize ratio. There.
Wow. And I'm guessing, let me think, 8 kilos?
6.5.
6,
So
right.
you're close. It's got a pretty good power to weight ratio.
I'm feeling weak this morning. 6.5
Fair
kilos. It is an amazing power to weight ratio. There's not a lot of heat sink in here. You trying to tell me something?
Yeah. It's next generation silicon carbide based power electronic tech. It's cool. It's very cool.
And it's got some little fans I can see through the gaps here.
Yep.
Are they continuously on?
No, they'll throttle up as needed basically.
Right.
So yeah.
Oh, wow. So if it's in a hot environment, it'll thermally manage itself.
Yes, that's
Yeah.
right. So thermal throttling, all the active safety functionality that you'd expect. And onboard ground fault detection, which makes life easy. No more earth guards.
Ground fault detection built in.
Yes,
Cool.
on the battery and PV side.
Okay, I never really thought about it. So the PV side's kind of been a requirement once you go over 120
That's
volts.
right. Yeah.
But you've got it on the battery side as well.
Yeah, we're sort of just preempting that,
Yep.
that it makes sense to monitor the whole system.
Oh, nice. Wow. Now, I remember when you've had a few versions over the time. The one before this had a little screen on here, and
Yes.
it caused a little confusion for me because I was looking for the buttons on the unit to program it, and then you told me just touch the screen, Glenn.
Touch screen. Yeah, that's right.
So what do I do? Touch this now?
No. So now we're a little bit more up with the. We were up with the times with the touchscreen, but we're a little bit more up with the times now. We've gone to it's all software and apps and things like that.
So what is this little white strip here for?
That is your status indication and soon to be charging indication as well. So you'll be able to see the faster it pulses, basically the faster it's charging.
Oh, it's a LED train, so
Yes.
it'll actually move in
Yeah.
a direction.
Yes. So that's
So charging is in one. Does discharging? No.
no, because we can't track that
You
because
can't track
we're
it, yeah.
charging that. But you'll be able to see if the PV is generating at a
All right.
which is we feel is kind of a lot easier for customers just to be able to see a strip that indicates it's charging rather
Yep.
than trying to read a screen and see they got a couple of thousand watts of PV or their voltage, and it was kind of the LCD was cool for everyone that was more technical, but it was a little bit difficult for the end customer.
I'm a big fan of simplicity for the customer.
Yeah.
I think the technical stuff's good for installers and engineers, but
Yeah.
customers want to know: is it working?
Is it working? Is there power going into my batteries, basically? So yeah, we kind of keep it simple.
So it looks like you got back entry here.
Yes,
So you'll just float on the wall, basically, won't it?
pretty much. So we've gone away from our flange mounting brackets, and now you've got just a standard mounting bracket plate that's bolted to the wall, and then this just gets.
Oh, I see. There's little
Yeah.
keyed holes there. So, like many systems now, the mounting brackets are
Yeah.
independent.
Yes.
Oh, that makes it very easy.
It does. So it's no more holding it on the wall and trying to screw it in
Yep.
at the same time, which
And you've
wasn't
got
ideal.
25 mil knockouts by the look of it.
Yeah, so we're standardised on 25mm entry ports, front and back.
Why is there 3?
Comms,
Oh, okay. So
Yeah.
battery, PV, and comms.
pretty much.
Right.
Or
Oh,
Earth.
nice.
Yeah.
And let's have a little look inside. So we've taken the screws out already. So do you want to open it for me?
Yeah, absolutely.
So what are we looking at in here?
So you're looking at your standard I/O input/output ports.
As your pointer.
Pointer. So your PV connection, your positive negative.
Yep.
Your battery connection, positive negative. And then we've got daisy chain Modbus 485 and daisy chain CAN bus as well.
Oh.
So you can go in and out.
Okay, so you can talk to smart batteries.
Exactly.
Wow.
Yeah, so makes life easy. And then we've got a USB-C diagnostic port because we're a little bit edgy like that. That's how you know the product's current. I mean, if it's got a USB-C port.
Oh, I see. It's daisy chain because you've got two.
Yeah, so
right.
So if you've got 5
Yep.
units on the wall, you can
Yep.
just go in and out on each of them and connect them all up with one.
What about termination?
Like 120 ohm resistor.
Yeah.
That's already there.
So those two pins there, got a built-in 120 ohm.
That's it.
Oh, thank
just
you
jump
very
that,
much.
And it's all done. No more weird, janky plug things with
Yeah.
resistors in them.
I remember a competitor sending a product, and we eventually realised we didn't have the termination resistor, and they said, "Oh, you just get your own. We don't provide it." Oh yeah, everyone has a 150 ohm
Yes, because
resistor.
I can go down to J-Car and get myself a 120 ohm termination RJ45.
At the back
Yeah.
of Whoop Whoop. Yeah.
Yep. Yeah. We figured that's probably a necessity.
Now you've got a onboard fuse. What's that about?
That's additional safety, basically.
Yep.
So we do, the standards now require that you do have a point of disconnection on the output of the unit, but we also like a point of disconnection inside the unit, just to basically make sure that in the event of a fault, the controller is fully isolated from the battery.
All right. It looks like you've got some mobs here, these little blue lollies.
Yeah, so the blue lollipops, they're basically for lightning protection.
Yep.
So additional protection for the controller in the event of a high lightning environment. So
Yep.
we designed these to basically go into any scenario.
Yep.
Yeah.
Wow. Look, take you back in time before you were born, 1991.
Right, yep.
My first AERL. In fact, oh my God, it's up here.
It's on the shelf.
It's on the shelf.
Oh, jeez. That's a blast from the past.
I think it was a 900B, something like that.
Sounds about right.
Yeah, 900B. So 1991. I actually had two of them.
Yeah, right.
And we had a lightning storm.
Yep.
Blew up the inverter. Blew up half the appliances in my house.
Yep.
Didn't blow this up.
Sounds about right. Yeah, they were. I think they had quite the reputation of being absolutely bulletproof.
Wow, it's pretty dusty. Let me just look at that. It's been sitting on the shelf a while. Yeah, 1991. So
You wouldn't believe how many of these are still out in the bush that just work. Like they're what, 30 years old now, and they're just still going.
Yep.
Which is ridiculous.
And they have this wonderful little where is it? Oh, it's popped inside. There's a little wire that you adjust.
Yeah, so we didn't have fancy apps or software back in those days. It was dip switches and little wire links, basically, that set your float voltage and all that sort of stuff.
So this actually kind of saved my ass because I had put the PV array on a separate building to where the batteries were.
Right.
And so we had quite a long run of cable, and it was back in the day where your battery voltage was your PV array voltage, and the cables would have had to be huge. But this allowed me to go up to 100, 3 panels in a string, I think it was.
Yep.
Well, these were actually 6 panels because they were 12-volt panels. So
right.
Back then.
Jeez.
So get 6 panels in a string and not have to run huge cables.
Yeah, they were quite the game changer back in the day. It was just nothing like them.
Yep. The manual was something else too.
Yes, the manual. It was definitely written by an engineer. Let's put it that way.
I think an engineer who was very into ecology because he saved on paper. The typeface was small and the line spacing was almost non-existent.
Well, look, I guess he just figured you probably had a microscope somewhere, that, just so you could
microfiche readable.
Yeah, that's it.
But fantastic unit. So, boy, from 1991 to 2022.
Yeah, that's a lot of history over that time frame. But no, we've certainly come a long way. They look a little bit different now.
So this contained the early algorithm that your dad wrote.
Yes.
How much has it changed?
So this version has the algorithm. It's changed a lot.
Mm-hmm.
So me and the current team wrote the algorithm in this one.
All right.
So if you were to put them side by side, I think you'll get more power out of this.
Probably a bit faster.
Bit faster, yeah.
Yeah.
It's not a fair competition though, because we got microcontrollers now.
Yeah.
But yeah, so there's certain parts of it that historically date back, but a lot of this is sort of newer current gen stuff.
And features like shadow scans, is that something?
So yeah, we are looking at things like that, and things like PV array degradation tracking and stuff like that.
All right, diagnostics.
Yeah, diagnostics. All little fun little value add scenarios that sort of help you get the most out of your array.
I mean, I've seen...
I'll tell you when to clean it anyway.
Yeah, well, that's a thing. It's enough just to know it's working. A lot of people don't even notice that their system stopped working because they don't monitor it.
Yeah.
But yeah, the ability to adjust and track the performance of a PV system has real value for a customer, because it's a 20-year investment typically.
Yeah, that's right. And probably a year in, you'll find that you're actually losing a good percentage of that power to some dirty panels.
So because you've got comms ports there, CAN and Modbus, does that mean you can communicate with a cloud service? Or?
Yeah, so we've got, it's not released yet, but we've got a comms hub module coming that'll talk back to our online cloud service for remote monitoring and doing all that sort of fun stuff and configuration.
Right.
Yeah.
So what's next? What comes after this?
Oh, who knows? I'm kind of quite over R&D for now, but we'll see. Ask me again in about 6 months' time, and we'll see what we can cook up.
I mean, this is a wall-mounted unit. Is there anything that's going to fit into a rack?
Yeah. So there's definitely. So this has a twin or a brother. So there's a SRX-R generation of chargers that are imminent, which are basically the rack mount version of these.
Right.
So a lot of installers will be familiar with sort of the rack mount style batteries these days. Now we've got rack mount style chargers. So you can put basically a 2U shelf in a cabinet and put 8 kilowatts of PV nominal per shelf, which works out to be a bit over 10 kilowatts of PV per shelf.
So it'll be 2 MPPTs then?
Yeah, 2 MPPTs per shelf. Yeah. Yep. So they're a similar size to this. So slot one in, slot the other one in, and go from there.
Right. Wow.
Yeah. Which is cool, because the biggest issue with these sort of products is, like, when it comes to end-of-life serviceability, to swap something like this out, you'd have to power down the whole system, and it's more a big thing for utility scale applications, but it makes life easier for everyone. End of life on a product like this, you have to shut down the whole system, go out to site, decommission it, put a new one in, replace it. It's a bit of a pain. Whereas with a rack mount style system, right, they're effectively hot swappable. So you have a module go down, so you've got significant redundancy by nature, but if you have a module go down, it's a case of turn off the PV isolator, pull it out, put a new one in, and your system's back to full capacity.
Wow. So there's no wiring?
No wiring.
Really?
Which means, for example, the biggest benefit of that sort of scenario is in very remote applications, right? Because of the fact there's no wiring, anyone can swap out a module. Provided the system's been isolated.
You don't have to be licensed.
You don't have to be licensed. So if they're, say you've got a system that's 2,000 kilometers inland, and it was going to cost you $10,000 to fly out there for 2 days to swap it out, you can just ship out a module and someone else can do it, and you can monitor the whole system remotely.
Wow. Remote hands, they call it. Yep.
Yeah, so it's in terms of, like, and you think about it, if you've got hundreds and hundreds of systems deployed, this becomes very unmanageable very quickly in terms of maintaining those sort of systems. Yeah.
So in terms of off-grid systems, the move really was away from MPPTs a decade or more ago towards AC coupled systems, but I've noticed the move coming back.
Yeah.
What do you think? Why is that happening?
Well, I guess the biggest aspect of that probably is the fact that grid solar took off. And grid solar really funded or drove a lot of investment into inverter tech, which then sort of resulted in more sort of emphasis being put on AC coupling. And basically, as a result, MPPTs didn't get the investment or development to keep up. So they just, when you put them side by side, up until recently, you've had, you're looking at a Victron 250 70 amp MPPT versus a Fronius 600 volt input with the ground fault detection on board. And it just doesn't quite stack up. And now that we've got an alternative that actually does compete with AC coupling, I think we'll see some change there. But also the biggest secondary driving factor is just timing. We're now at the point globally, I think, that battery storage is coming into its own. Batteries, PV got really cheap really quickly, so AC coupling made sense. But now we're at a point where battery tech is becoming really it's everywhere. And so people are starting to consider centralizing their system design around batteries themselves. And for a battery-centric system, so something where the loads are effectively predominantly outside of PV generation hours, a battery-centric DC-coupled system makes sense. If you've got high daytime consumption, an AC-coupled system makes sense. So I think we're seeing, it's just a combination of factors, but predominantly timing, I think, is the biggest driving factor at the moment. Batteries are getting cheaper.
I think from an off-grid perspective, the black start protection too.
Oh yes, yeah, absolutely.
For those who are not familiar with what I'm talking about, black start protection is basically you don't need to have a battery inverter energize a grid, a grid-forming system for AC-coupled inverters to synchronize with. It sounds a bit complicated, but basically AC coupling works fine until your grid-forming inverter shuts down because of low battery voltage. But an MPPT doesn't care. It goes low battery voltage, sun comes out, charge battery.
Yes, that's absolutely right. So if the whole system goes down, the MPPT can bring it back on.
Yeah.
And they'll bring the grid-forming inverter back up, basically.
And I've seen now that a lot of installers put in, even if they still love AC coupling, they'll put in an MPPT as their sleep easily at night option for off-grid systems.
Well, it's not a self-recovering system without one, right?
Yeah.
And it's, and any sort of system that's remote needs to be self-recovering. Like you can't lose power because by extension you generally lose internet or telephone.
Yeah.
And then you can't tell someone you've lost power and send help. Yeah, design redundancy is absolutely key for anything remote power.
I think there's another reason too that DC coupling has an advantage, is which you can size your DC charging source to your kilowatt hour demand.
Yes.
Not to your maximum AC demand.
Yes.
And whereas an AC coupled system, the inverter that charges the battery has to be big enough to accept all the AC coupled solar.
Yes.
So you might actually have a telco site where your loads are 2 kilowatts, 24 hours a day, but that's 50 kilowatt hours a day of energy.
You need a small inverter, but a lot of charge.
You need a small inverter and a lot of charge. So you build the chargers to suit the kilowatt hours.
That's right.
And the inverter to suit the load.
That's it. Yeah, and that makes the most sense, really, at the end of the day. And I think that goes back to the fact that AC coupling was born out of the fact that inverter tech was just easier to use. It got more investment, it became more prolific, and it was easy to use. And now we have DC coupled options that are coming onto the market, like the SRX 600, that offers the same easy installation and benefits of AC coupling, but allowing you to go back to a system that's effectively properly sized.
Yeah.
So that's why this is so exciting.
In terms of ease too, look, you've got 2 ports, a battery port, a PV port, and if you feel like it, a comms port if the battery needs it. Yeah, it's pretty easy.
We've had the questions in terms of how do you install them are always quite quick and short, the answers for those. It's pretty self-explanatory.
If someone did do the wrong thing and, reverse connected the battery, what's going to happen?
The battery, well, you're going to blow a fuse.
You're going to blow a fuse. Okay, well, it's better than blowing up the whole thing.
Yeah, well, the fuse basically, so because of the fact that a battery isn't effectively a current limited source, we can't just use a diode to sort of handle the reverse current. So a lot of scenarios, for example, on the PV side, we've got a big hefty diode on there, so if you put them up backwards, it just short circuits the array and can handle it continuously. So PV backwards, no problems, but because there's it could be 1,000 amps on the battery side, we have to blow a fuse, unfortunately.
Well, fair enough.
So that's, don't wire the battery up backwards, you'll regret it. If you wire the PV up backwards, you're all right.
Now, there's a hot topic at the moment. It's called the 1.25 times short circuit rating of the input to an MPPT.
Yeah.
What is your ISC rating?
So we are rated to 18 amps ISC. So this is a 600 volts, so it's a single string MPPT.
Yep.
So you'll do anywhere from 10 to sort of 14 panels straight into it.
Right.
So that basically means that it has enough headroom to give you that 1.25.
Yep. So that would be up to about 14 amps on the PV array times 1.25 would be under 18 amps.
Yeah, pretty much. I think it's a little bit less than that in reality, but we like to put lots of headroom in things.
Oh, that's great.
Yeah.
Wow. Okay. So you're not really hit by this ISC problem.
No. Thankfully, because we were in the late stages of design at that point in time when that all happened, we were like, hey, we can deal with that quickly. So we did.
Oh, good one.
No.
Cool. Hey, well, Peter, thanks for dropping in. I know you're just passing by, and I just grabbed you and pulled you into the studio for a quick chat.
That's all right.
It's always good to catch up.
Yeah, no, I absolutely love coming to visit here. It's always fascinating. Good to chat.
Okay. Thanks, Peter.
Thanks, Len.